Hi everyone, this is Dr. Kingston, and in this video we're going to be talking about the sublingual space. To do that, we are going to describe the contents of the sublingual space and talk about their spatial relationships. So the sublingual space sits inferior to the tongue and deep to the mucosa that makes up the oral floor. It's part of the oral cavity, so it shares that inferior border of the mylohyoid muscle. So if we are looking at the images here, mylohyoid is right there. Okay, laterally then, if we follow it up here, it's going to be surrounded by the mandibular body that houses that lower tooth row. Okay, and then medially, its boundary is the genioglossus muscle. And we haven't encountered genioglossus just yet, but you can see it here on this image on the right. And there are two of these. There's one on the right and one on the left. These are going to extend back from the genial spines, which are on the mandibular body, just posterior to the incisors here. And they stick up into the body of the tongue so that when they contract, their function is going to be to protrude it or stick it out. So because of their location here, it also helps to separate the sublingual cavity into right and left portions. The sublingual space is considered a fascial space. So just like the other fascial spaces that we've covered in this course, they communicate with other fascial spaces surrounding them. You learned this pathway here, starting at the infraorbital canine space and heading all the way down into the retropharyngeal or danger space quite a while ago now, but we're going to add a little bit to it. So the sublingual space communicates directly with the submandibular space and the lateral pharyngeal spaces around the posterior border of mylohyoid. And this is a relationship that we talk about a lot with the oral cavity. We say around the posterior border of mylohyoid. It's literally just kind of going whoop around the back edge of it. And that's how a lot of structures enter the oral cavity, and it's how a lot of these spaces communicate, all right? So that mylohyoid doesn't entirely close off. It doesn't butt fully up against the neck. It kind of loosely butts up against it, and structures and fluids are able to move in and out of there. So as I was saying, we're going to see a number of structures like the lingual artery and the hypoglossal nerve pass deep to it to get into the oral cavity. And where you have structures passing through like this, you also have fascia surrounding them. So that's what creates this communication here. And again, these communications provide a pathway for the spread of infection and metastasis. And that lateral pharyngeal space in particular provides a direct pathway down to the retropharyngeal or danger space. So as a dentist, you're going to need to be very cognizant of infections that can occur here, including infections of the mandibular teeth. In addition to having a direct route to the thorax, infections in the sublingual space can be life-threatening without ever spreading. Infection can cause what's referred to as Ludwig's angina, which is cellulitis or edema, so fluid retention and swelling in the sublingual and the submandibular spaces. Okay, so down here on the diagram, sublingual space we see in bright green, submandibular space is right below it, highlighted in purple here. All right, so swelling in these spaces, and if I bring your attention over here to the X-ray image, you can see as this dark fluid kind of filling up these spaces. And what this ends up doing is forcing the tissues of the pharynx to pinch together and close off. So in this case specifically, what we're seeing is as these spaces swell up, they force the tongue up and back into the airway. All right, this is an emergency and needs immediate treatment. The person in this image here did not have full closure, and according to Radiopedia, where I stole the image from, he was able to get full treatment before breathing issues really became too severe. For being such a small fascial space, the sublingual space is home to a surprisingly large number of structures, and these tend to fall into one of two categories. So we will have neurovasculature for the tongue, and then we have salivary glands and their associated ducts. So because there are fewer of them, we're going to start off taking a closer look at the salivary glands. The largest gland that exists entirely within the sublingual space is the sublingual gland. Kind of unsurprisingly, it's also the smallest of the three big salivary glands because it has to fit in such a tiny, narrow space. So you can find its location from the oral cavity by identifying the sublingual fold of mucosa that covers its surface. So you can see that here and there. The actual gland sits deep to that mucosa, and it sends up many small ducts that open directly onto the oral floor. So you can see that right here in this diagram, and all these little things sticking up there are its many little ducts opening up onto the oral floor. The duct of the submandibular gland, which for the most part it sits on the opposite side of mylohyoid. So remember, you saw it down in the neck, down in the submandibular triangle. The duct for that gland is also going to travel through the sublingual space. The deep portion of the submandibular gland kind of sneaks up over that posterior border of mylohyoid, like everything else, and it sends its duct anteriorly to open at the sublingual caruncles. So remember, sublingual caruncles are these little bumps on either side of the lingual frenulum. And unlike the sublingual gland, this guy only has one duct. So here is the deep portion of the gland sticking up over mylohyoid, and it is going to send its duct through the sublingual space to open up here at the sublingual caruncles. These salivary glands are close enough neighbors that they share an innervation pathway. Salivary glands are going to get parasympathetic innervation to make them secrete. And in this case, that parasympathetic pathway originates with the facial nerve. These fibers are going to jump off with a very early branch in the middle ear called the chorda tympani. There it is. And this travels out into the infratemporal fossa, where it is going to join up with a branch of the mandibular nerve, or the third division of trigeminal, called the lingual nerve. Now, the lingual nerve is already carrying back somatic sensory from the anterior 2/3 of the tongue. So it's heading in the general direction that the chorda tympani fibers want to go to. So they jump on that, ride it into the sublingual space, and there they synapse in the submandibular ganglion. The lingual nerve actually has a very distinct relationship with the submandibular duct. So the duct carrying saliva from the submandibular gland. The lingual nerve enters into the sublingual cavity here, and you can see the swelling here is actually a really nice representation of the submandibular ganglion. But that lingual nerve is going to loop underneath the submandibular duct and then back up to approach the tongue. So it ends up cradling the submandibular duct very much like you would cradle a baby. All right, so you can see this relationship in the image here. Again, it's going to come into the sublingual space, loop underneath the submandibular duct, and then come back up to get to the tongue. That pathway is a good jumping off spot to talk about the neurovasculature that supplies the sublingual space. So in addition to that lingual nerve, we're going to find one other large nerve here, and that's the hypoglossal. Hypo meaning under, glossal meaning tongue. So the hypoglossal nerve is carrying somatic motor innervation to the intrinsic and extrinsic tongue muscles. And in order to reach them, so here we can see it in the neck, it's going to pass, again, superior to the posterior border of mylohyoid to enter the sublingual space. And then it travels fairly deeply within that space to approach those tongue muscles from below. So that's how he gets his name. Arteries found in the sublingual space are branches of the lingual artery, which itself is a branch of the external carotid artery. As it enters into the sublingual space, so just like hypoglossal nerve and everything else, it's going to sneak up over the edge of mylohyoid. As it does that, it gives off the dorsal lingual branch there. And then the bulk of the artery is going to continue traveling deep to a muscle called hyoglossus, which we can see on here. Let me pull up my pen. All right, so hyoglossus is these fibers here, and you can see its cut edge here and here, okay? So here's the bulk of the lingual artery then that's going to pass deep to hyoglossus. Okay, and it's going to split into two branches anteriorly. We've got the deep lingual artery, which kind of confusingly is actually going to head up into the body of the tongue and supply its inferior or ventral surface here. And then we have the sublingual artery, which stays down in the sublingual space and will supply the sublingual gland and the other tissues that make up the oral floor. The lingual vein then is ultimately what is responsible for draining the submandibular space, and that will drain back to the internal jugular vein. The tributary pattern that forms the lingual vein follows pretty close to the branches of the lingual artery, but it's not exact. So anteriorly, again, we have deep lingual and sublingual veins that run with their partner arteries. But you'll notice posteriorly that these are going to drain back, so here and here, to something called the vena comitans for the hypoglossal nerve, okay? And that is just a vessel that travels along with the hypoglossal nerve, and it is going to receive some of the tributaries for things going back to the lingual vein. All right, so let's talk a little bit more about that hyoglossus muscle. So as I was saying, it is an extrinsic tongue muscle like the geniohyoid. It moves the tongue around, and in this case, it is connecting the ventral portion of the tongue down to the hyoid bone. All right, and it actually presents a little bit of an obstacle for these neurovascular structures entering into the sublingual space here, okay? To get where they're going, these structures are either going to have to travel medial or lateral to hyoglossus. And as you can see from all the blue labels on the slide, most of these are going to be traveling lateral to hyoglossus, so they ride its lateral surface into the sublingual space. The one big one that is going to travel medial to hyoglossus is the lingual artery. So as that comes in, instead of going over the lateral surface, it dives deep, and that added layer of protection is a good thing for an artery to have, okay? So the more tissue surrounding an artery, the better it's protected. The hyoglossus muscle also separates the sublingual space into a posterior and anterior portions. The hyoglossus then is sitting posteriorly. So the entire belly of this makes up the posterior part of the sublingual space, and everything up here then is in the anterior sublingual space. So anteriorly, we get a nice clear view of genioglossus that divides the left sublingual space from the right. And we can see a lot of the neurovasculature here sorting itself out to get to the specific structure that it supplies. All right, so for instance, this is where we see the cradling relationship between the lingual nerve and the submandibular duct. Okay, so lingual nerve going underneath the submandibular duct. We also find the deep lingual vessels making their way up to the ventral surface of the tongue. And we see the sublingual vessels and hypoglossal nerve have continued into the deep sublingual space. All right, one thing that I want to add here as well, if you look at these vessels, okay, so they look like they're fairly decent sized vessels. And as they come up to the edge of the oral cavity, it looks very much in a two-dimensional picture here like they just end. And that's not really what's happening here. So number one, these really aren't as big as the sketches make them look. But even if they were, they don't just peter out and end here. What they're doing is actually anastomosing right to left around the genioglossus muscle here. Okay, so the right artery meets up with the left artery, and they have a nice little anastomosis there. And that brings us to the end of the material for this session. So here is your review question. I want you to identify the structure that those two little red arrows are pointing at. So the indicated structure enters the sublingual space, traveling blank to the hyoglossus muscle. All right, and the correct answer here is B, medial. So hopefully you correctly identified this as the lingual artery. And one of the ways you can identify the lingual artery is by its relationship with hyoglossus. So hyoglossus you can see here, coming from the ventral portion of the tongue down to the hyoid bone, which is not terribly visible in this picture, but the muscle sure is. And we can see that the structure is coming from deep to the hyoglossus muscle and traveling into the sublingual space. So with this relationship, we know that this is the sublingual artery passing medial to hyoglossus. And that is going to bring us to the end. Thank you for joining me.